In today's lesson, we're talking about the seasons and why we have seasons. The amount of sunlight coming from the sun doesn't change much. It does vary some. But the amount of sunlight received at a location throughout the year does change a lot. And that gives us seasons. Well, why does it change? We have seasons because the Earth is tilted on its axis as it revolves around the sun. That is the big thing. We have seasons because the Earth is tilted on its axis. It's not because we're closer to the sun or farther from the sun. A lot of people think that, but it's not. We have seasons because the Earth is tilted. That's going to cause two things. And before I just go into the notes on those two things, I want to show you what the Earth would look like from space. And maybe we can learn some of this stuff by just looking at that picture. So I'm going to go to an online geochron, and I'll show this in class with my real one that's on the wall. But what the geochron shows is basically shows a satellite image of the Earth, and it shows where there is shadow and then where there is sunlight. And I just picked June 23rd, 2014. I'll change this as we go through. But June 23rd, and actually let me change it to the solstice. We're going to talk about the solstice is an equinox, so let me change it to the summer solstice. Okay, and that's June 21st or 22nd. When you look at it now, you'll see that in North America, or in the Northern Hemisphere, there are lots of hours of sunlight and a little bit of darkness. Well, if there's more hours of sunlight than there is darkness, it's going to be warmer. So it's going to be summertime. But if you look in the Southern Hemisphere, you'll notice that there are more hours of darkness and less hours of sunlight. So it's going to be wintertime. It's going to be colder. If you get above here, above the Arctic Circle, there's a reason why the Arctic Circle is at the line of latitude that it is, they will have 24 hours of sunlight on June 21st above that. So on June 21st, the Arctic Circle gets 24 hours of sunlight. Anything north of the Arctic Circle is having more than 24 hours of sunlight. Okay, they might have multiple days of it. And I can kind of show that. Let me just go to maybe June. Let's go to June, how about June 1st? And you can see that they still had 24 hours of sunlight up there. Let me go to July 1st. You can see that they still have 24 hours of sunlight up there. In the opposite way, the South Pole has 24 hours of darkness. The sun never rises. So in the North Pole area, the sun will just go around in circles in the sky, but never make it below the horizon. In the Southern Hemisphere, it's the moon going around in circles and going through phases. Okay, so that's summer. Okay, Northern Hemisphere summer, we have more hours of sunlight than we do darkness. Also, the sun is more directly overhead, so the sunlight's more intense in the Northern Hemisphere. So now what if we go opposite season? So instead of June 21st, let's go to December 21st, the winter solstice. Now we notice basically that shadow line has flipped. So if you're in the Northern Hemisphere, we have lots of hours of darkness and fewer hours of sunlight. So it's going to be colder. Southern Hemisphere, though, is opposite. They have lots of hours of sunlight and fewer hours of darkness, so it's going to be warmer. So it's summer for them, but winter for us. And again, you see the same thing that we were talking about, but reversed. So now the northern pole, or north of the Arctic Circle, has 24 hours of darkness. South of the Antarctic Circle, it's 24 hours of sunlight. Well, what if I go to the equinoxes? So let me go to the vernal equinox, which would be March 21st. Kind of interesting. Now you notice these shadow lines are straight up and down. They're parallel. What it's showing you is that Northern Hemisphere, 12 hours sunlight, 12 hours darkness. Southern Hemisphere, 12 hours sunlight, 12 hours darkness. North Pole, South Pole, everywhere is getting 12 hours of sunlight and 12 hours of darkness. The sun is directly overhead at the equator now. Okay, it's most intense there. So that's the equinox, equal day and equal night. If I go to September 22nd or 23rd, we have the autumnal equinox. Again, it looks the same way. We have equal numbers of hours of sunlight and equal number of hours of darkness. Okay, so it's kind of our spring and fall. So that's what the Earth's tilt does for us. Again, the Earth's tilt is going to cause a changing amount of the hours of sunlight and then a changing intensity of the sunlight. So now we're going to go through our notes, and we'll look at this online with our geochron also. So the tilt of the Earth causes two things. First, it causes the number of hours of sunlight to vary at a location. We just saw that. So different amounts of daylight and darkness at different locations throughout the time of the year. The more sunlight you have, the warmer it's going to be going into summer. Then the second thing the tilt causes is the intensity of the sunlight to vary at a location. So the angle at which the sunlight hits a location is going to change throughout the year. If it's more directly overhead, it's going to be hotter, summertime. If it's less direct, it's going to be cooler, wintertime. So you have on your notes a picture just like this that's showing the Earth going around the sun. And again, you see the key thing here is that the Earth is tilted. Okay, the Earth is tilted on its axis. Again, that's what causes the seasons, not the closeness to the sun. And we're just going to go through and we're going to look at this and see what that does. So it doesn't really matter where we start. Let's just start in summer, June 21st or 22nd. Okay, so June 21st or 22nd is going to be the summer solstice. And if I kind of draw a shadow line on here, it'd be right here from the Arctic Circle edge going down to the Antarctic Circle. So this part of the Earth is in shadow. Okay, and the Earth is going to spin around and around and around. This is in Northern Hemisphere. So I'm going to put in Northern Hemisphere. It is the longest day, shortest night. So longest day, shortest night is what that says. So you look at in Texas here, we're going to have can't draw it very well, lots of hours of daylight and fewer hours of darkness. It's going to be something around 14 hours of daylight and only 10 hours of darkness. Well, that's going to make it warmer. It's going to make it summer. We have more sunlight than we do darkness. The farther north you get, the more hours of sunlight they have and the fewer hours of darkness. You get to the Arctic Circle, 24 hours of sunlight. Anywhere north of the Arctic Circle, they've had more days of 24 hours of sunlight until you get to the North Pole where they've had 24 hours of sunlight for a long, long time. You go to the Southern Hemisphere, and it's the opposite. They have fewer hours of daylight and more hours of darkness, so it's winter for them. So it's winter in the Southern Hemisphere. At the South Pole, or south of the Antarctic Circle, they're going to get 24 hours of darkness, so 0 hours of sunlight compared to 24. Well, the Earth continues its journey around the sun, and we get to September 21st or 22nd. Now, the Earth the axis isn't pointing towards the sun. Okay, we're kind of tilted 90 degrees, where it's pointed off to the side. So you can't really see it on here, but the shadow line would be basically right from pole to pole, the beyond, kind of the backside there. So every place on Earth is going to get 12 hours sunlight, and then the back, 12 hours darkness. 12 hours sunlight, 12 hours darkness. Okay, so this is going to be the autumnal, A-U-T-U-M-N-A-L, autumnal equinox, September 22nd or 23rd. So it's equal day and night everywhere. So you can write that down. Equal daylight and darkness. That's what that says. I'm going fast. Everywhere. Okay? So equal daylight and darkness everywhere. 12 hours each. Because we're not pointed toward the sun, we're not pointed away from the sun. You look at the intensity of the sunlight, the sun is shining intensely on the northern hemisphere, also making it summer. Now the sun is shining most intensely right at the equator, so it's going to be equal on both halves. That's why they call it an equinox, equal day and night everywhere. Well, the Earth continues its journey. Now we get over here, and we get to winter. We're going to get to the winter solstice, December 21st or 22nd. Now, the axis of the Earth in the northern hemisphere is pointed away from the sun. I'm trying to draw my shadow line on here again, so this part is in shadow. So in the northern hemisphere, we're getting more hours of darkness and less hours of sunlight. So we might only be getting 10 hours of sunlight, but 14 hours of darkness. Well, it's going to be colder. North Pole isn't getting any sunlight. You can see that. Okay, anywhere north of the Arctic Circle. It goes around and around and around and around and around and never gets into the sunlit part. Opposite down here, you go around and around and around and you're always in the sunlight. So it's going to be 24 hours of sunlight there. The equator is still getting 12 hours sunlight, 12 hours darkness, just like it was here, and it was getting it here too, 12 and 12. The equator is always halfway between. It's equal. After winter, the Earth cruises around this way, and we get to the spring. And we call the spring equinox the vernal, V-R-N-A-L, so the vernal equinox, March 21st or 22nd. And again, we're not pointed towards the sun, like in June. We're not pointed away from the sun, like in December. We're kind of pointed 90-degree angle, like we were here. Now you're seeing kind of the whole shadow side of the Earth, whereas in this picture, in the autumn, you're seeing the whole sunlit side. So again, it's going to be equal daylight and darkness everywhere. So you can write that same thing down, equal daylight and darkness everywhere. For here, I didn't write it down here. Maybe I should have. Maybe I should have written down in northern hemisphere. It's going to be the longest night and shortest day. Okay, longest night and shortest day. And you notice that the sun was overhead in the southern hemisphere, not in the northern hemisphere. So then we get our definitions. The solstice is just the most unequal amount of daylight and darkness, what we just saw. June 21st or 22nd. Winter solstice, December 21st or 22nd. Equinox is equal daylight and darkness everywhere. And you see the equinox is on March 21st or 22nd or September 22nd or 23rd. I think we're going to pause here in our lesson. We'll pick it up in the next one so we can talk a little bit more about the intensity difference.